Every day, the human brain processes millions of distinct data points. Most of that information vanishes almost instantly, yet a single specific detail will often bypass these internal filters and last a lifetime. Memory functions as a multi-stage mental pipeline. It is a continuous, active process of encoding, storing, and eventually retrieving information. This pipeline acts as an aggressive filter. It strips away the noise of daily experience to preserve only the data necessary to shape our behavior and long-term knowledge. Understanding the mechanics of this cognitive pipeline provides the blueprint for how we retain complex knowledge. Psychologists Richard Atkinson and Richard Schifrin mapped this architecture with the multi-store model. They identified 3 distinct chambers for data: sensory, short-term, and long-term storage. Alan Baddeley and Graham Hitch later expanded on the middle chamber. They demonstrated that short-term storage is an active processor, which they termed working memory, the space where the brain manipulates and combines new data in real time. Finally, Endel Tolving mapped the long-term vault by dividing it into 2 zones: episodic memory for personal experiences and semantic memory for general facts. These researchers provided the structural map for how a fleeting thought survives the brain's filters to become permanent expertise. To see this pipeline in action, consider an analyst named Joseph attending a workshop. He is looking at a slide filled with new, dense financial formulas. In the sensory memory stage, Joseph retains the complete visual image of the slide for only a fraction of a second before the image begins to decay. As he pays attention, the formulas enter short-term memory. This is a volatile environment. Without active rehearsal, he will hold this information for approximately 15 to 30 seconds before it degrades. Joseph enters working memory when he begins an exercise. He must actively manipulate these numbers to apply formulas before the window closes. If he fails to engage with the data in time, it dissolves. The temporary data is lost. For data that survives the gauntlet, the final destination is long-term memory. This vault holds information for days or decades, organized into 2 major streams. First is explicit memory, information we consciously recall. Joseph now holds a semantic memory of accounting principles, alongside an episodic memory of his instructor interaction. The second stream is called implicit memory. Through procedural memory, relentless practice transforms conscious effort into unconscious action. After repeated application, the data has been fully processed. The formulas Joseph once struggled to remember are now applied through a fluid, automatic reflex. This shift marks the transition from effortful, conscious recall to the automatic application of a skill. This cognitive architecture is the engine behind success across every professional sector. Educational strategies like spaced repetition and active recall are designed to work with this pipeline, moving information from the fragile short-term stage into durable long-term storage. Data analysts rely on a combination of these systems: working memory for comparing active datasets, semantic memory for accounting principles, procedural memory to navigate analytical software. Professional training programs focus on building procedural memory. By repeating specific processes, employees ensure that complex tasks like navigating internal software or conducting negotiations become second nature. In leadership, episodic memory allows managers to recall the specific context of past projects, using those experiences to inform current strategic decisions. Every industry functions effectively because the human brain is capable of filtering, encoding, and retrieving these targeted data streams. This mental architecture allows us to navigate our daily lives, recognizing faces instantly and moving through complex environments without conscious effort. The process follows a specific sequence. Information requires encoding, which allows for storage, which finally enables retrieval. Developing any high-level capability requires moving sensory data through this mental gauntlet, transforming temporary information into durable, usable knowledge.